Hi! Today's lesson is about the different types of reactions and how we're able to classify them. Our first type is called a synthesis reaction. Synthesis reaction. To synthesize something, it means to come together. And the same is true in our chemical reactions. What is it that's coming together? More than one reactant will come together to form one single product. And it's this one single product that we're going to use to help us recognize it. In other words, the most generic way that we can write a synthesis reaction is element A reacts with element B to produce compound AB. Those two reactants or two elements formed one product or one compound. A real-life example would be the synthesis of magnesium nitride. The element magnesium and the element nitrogen combine to form the compound magnesium nitride. The second type of reaction is called a decomposition reaction. Decomposition reaction. Something that decomposes breaks down. Same is true in our decomposition reaction. What is it that's breaking down? One single reactant. It's going to break down to produce two or more products. So how is it that we'll recognize the decomposition reaction? By it having one single reactant. What does that look like in its most general form? Here we have reactant, which is compound AB, and it breaks down to produce products A and B. Product A is an element, and product B is an element. A real-life example of that would be the decomposition of water. Water is a compound, H2O. It decomposes or breaks down into the two elements that make it up, oxygen and hydrogen. Our third type of reaction is called single replacement. Single replacement. Sometimes people call it single displacement, and that's fine. Means the same thing. Single replacement, single displacement. The idea behind this is a more reactive element will replace part of a compound. A more reactive element will replace part of a compound. The general format for this, then, would see an element and a compound as our reactants. And when the replacement occurs, we'll have the format of an element and a compound on the product side. However, they'll be different. So I'm just going to add like a little prime sign to show that the element and compound on the product side are different from the elements and compounds on the reactant side. Let's look at that in its most generic form. The reaction would look like this: A plus BC. Well, A, it's just a single atom, so that's an element. BC has two different ones, so there's my compound. And the description tells us that if element A is more reactive, it's going to replace part of the compound. So when I look now at my products, the compound, which again, it's new, so I'm calling it compound prime, A is now bonded in the compound with C. The only way that that could happen is if A came in and kicked out or replaced, hence single replacement, part of the compound. In this instance, it's compound B. So now on the product side, B, that part that got kicked out, that is our element prime. Based on the law of conservation of matter, the matter or the atoms that we're working with have to be the same. It's just how they're arranged is going to be different. Here the bond holding BC together is broken, and a new bond between A and C are formed. This is referred to as single replacement cationic because it's the cation of the compound, B, that was replaced. We could also have the anion be replaced, and that might look something like this. X plus QZ yields. Well, what part of that compound QZ is my anion? The Z. So if X came in and replaced the Z, that would be an example of single replacement anionic. So we do specify whether our single replacement is replacing the cation or the anion in the compound. Our fourth type of reaction is called a double replacement reaction. Again, sometimes you'll hear double displacement, and that's fine. It means the same thing. In a double replacement reaction, the cations of two compounds switch places. The cations of two compounds switch places. Looking at it, AB, the cation is A. That's going to switch places with the cation from compound CD, the C. And you'll look over here. A is now with D. It took the place of the C. The second replacement, hence double replacement, is that this cation C is going to take the place of the A. So now C is with B. A double replacement. The cations of the two compounds switch places. Our fifth and final category is called a combustion reaction. A combustion reaction is when anything reacts with oxygen. Because it's something reacting with oxygen, O2, because remember, oxygen's going to be diatomic, is a reactant. So for example, you can have something plus O2 and then the yield sign. And whatever it makes, it doesn't matter. As soon as you see oxygen, it's a gas, as a reactant, you know it's going to be classified as combustion. Oh, go back to double replacement. The format of this is going to be compound plus compound yields compound plus compound. Right? If the two cations are going to switch places, maybe we need prime and double prime and triple prime, because all the compounds are different. Sorry about that. So now that we've got the data or the notes for what we're looking for, let's now work together in class to practice identifying and classifying chemical reactions.